All right. Have you ever wanted to just totally defy gravity right from your own desk? Well, in this explainer, we're going to do exactly that. We're going to use just a few super simple things to make objects float like it's actual magic. So, let's dive in.
I mean, listen to that claim. Make objects float in midair forever. Wow, that's a pretty bold statement, right? Forever? But hey, that's the promise of this whole project. We're not just talking about some quick little optical illusion. We are building something that creates permanent levitation. So the real question is, how on earth is that even possible?
So what's the deal here? Is it some kind of trick? Smoke and mirrors? Or is there some real, clever science at play? Well, in this explainer, we are going to pull back that curtain. We're going to uncover the secret behind what looks like an impossible feat.
All right, Section 1, defying gravity at home. And look, we're not just talking about some abstract theory here. This is a real practical project that you, yes you, can build yourself probably right where you're sitting.
So here's the game plan. We are building a permanent levitation display that, honestly, just looks like a straight-up magic trick. The goal is to get a small object to hover and spin in midair, all powered by a single tiny battery. It is the ultimate desk toy, and I guarantee it's going to make your friends go, "Wait, how did you do that?"
Okay, now for the best part. You probably have everything you need to pull this off already lying around your house. Seriously, no fancy lab equipment, no special orders. Let's take a look at what you'll need from your junk drawer toolkit.
I'm not kidding. Look at this list. Some enameled wire, a battery, a couple of bobby pins, you might have to borrow those, a magnet you could probably grab off the fridge, and a marker. That's it. This is about as accessible as it gets. You can literally build this entire amazing thing from what you'd find rattling around in a drawer. Okay, you've got your parts together? Awesome. It's time to build. We're going to walk through this step by step, and you'll see just how ridiculously simple it is to put this whole magic trick together.
Okay, first up, you're going to make your coil. Super easy. Then, and listen up, because this is the most important part. This is the real pro tip. You have to scrape the ends of that wire. We'll talk more about why in a sec. After that, you just set up your base with the bobby pins and the magnet. And then, for the grand finale, you gently place the coil on its holder, give it a tiny little spin, and just watch the show begin.
So why is scraping that wire so absolutely critical? Well, see that enamel coating? It's an insulator. That means electricity can't get through it. It's like a roadblock. So if you don't scrape it off to get to that shiny copper underneath, your circuit won't be complete. And if there's no circuit, the magic trick fails. It's this one tiny little detail that makes the whole entire thing work.
All right, so your coil is spinning, it's hovering, it looks just like magic. But now, it's time for the big reveal. Let's unpack the science, because the secret here is all about one of the fundamental forces of nature. Okay, at the very heart of this project is something called an electromagnetic field. Basically, the second you run an electric current through a wire, that wire starts acting like a magnet. It's a temporary magnet, sure, but it's powerful, and it is the key to absolutely everything we're seeing here.
So here's how it starts. That battery sends its current flowing through our little wire coil, and instantly, boom, that coil stops being just a boring piece of wire and becomes an active electromagnet.
And this is where the action happens. The temporary magnetic field from our new electromagnet coil starts to interact with the steady, permanent magnet you placed on the battery. But they don't pull together. They don't attract. They repel. They are constantly pushing away from each other.
And that's it. That's the final piece of the puzzle. That constant push, that repulsive force, is actually strong enough to counteract gravity, lifting the coil right up. And because that push isn't perfectly balanced, it also gives the coil that little spin and keeps it going. It's this beautiful, self-sustaining dance of magnetic forces. So cool! What's really amazing is that this isn't just some cool party trick. You've essentially built a very, very simple DC electric motor. The exact same fundamental principle, using electromagnetism to create motion, is what powers countless devices we use every single day. So cool, right?
So, you've built it. You get the science behind it. So, what's next? Well, this is where the real fun begins. Now it's your turn to be the inventor, to experiment, to innovate, and to see just how far you can push your new creation.
Yeah, don't just stop here. What do you think would happen if you used a more powerful battery, like a 12-volt? Or what if you made the coil a different shape, like a square? Can you get it to levitate even higher? Could you suspend something else, not just the coil?
See, this super simple setup is really just a launchpad for endless experimentation.
You know, this whole project is really about bringing simple, inanimate objects to life, using the power of science. So, now that you hold the secret to defying gravity with, literally, parts from a junk drawer, the only question left is, what will you choose to reanimate next?